interpreting our results. Just like the Anderson-Darling test, which if you don't know much about that, make sure you check out this video where we go in depth in the math behind the Anderson-Darling test. But the KS test statistic, just like the Anderson-Darling test statistic, higher values correspond to a lower probability that the data originated from the specified distribution. So higher KS or AD test statistics mean that there is a lower probability, so they're more non-normal. There's more non-normality in your data. For p-values, a critical value is used to evaluate the p-value and then determine if we fail to reject the null hypothesis or if we do reject the null hypothesis. Generally, that critical value is going to be 0.05, but as always when it comes to critical values, please consult your organization and make sure that you are using what is documented there. So let's take a look at an example. You might notice these examples look very similar from our Anderson-Darling test video because they are. They're exactly the same because, again, the p-value is calculated the same way. So let's say we have a p-value of 0.08 and a critical value of 0.05. Our p is greater than or equal to our critical value. 0.08 is greater than or equal to 0.05. Therefore, we fail to reject the null hypothesis. The null hypothesis is the data follow a normal distribution. Therefore, since we fail to reject that, we assume that the data follow the normal distribution. Another example here is where our p-value is less than or equal to our critical value. In this case, p is 0.03 is less than 0.05. Therefore, we reject the null hypothesis. The null hypothesis, again, being the data follow a normal distribution. Therefore, we cannot assume the data follow the specified distribution. Therefore, we cannot assume the data are normal.